on this side of the plot, and the microbiome was enriched in Klebsiella, which is an opportunistic pathogen. So at 3 months of age, healthy babies and allergic babies has a different microbiome. Allergic babies have a microbiome which is depleted from bifidobacterium and enriched in Klebsiella. Does this matter? Yes, it does matter. If you look at the literature, there is now a growing body of evidence that indicate that a compromised microbiome in the first 100 days of life, in the first 3 months of life, is a risk factor for allergy and obesity. So after birth, what are the key factors that contribute to shape the early life, the baby microbiome? Here, several factors have been described to influence the development of the microbiome in early life. We are all fully aware that in early life, breast milk or human milk is the best source of nutrition for babies. First of all, human milk is a source of hydration. Human milk is a nourishing biological fluid that contains specific macronutrients in order to sustain the healthy growth and development of the babies. Human milk also contains living biological cells, such as immune cells, and also immunological components that contribute to build up a robust immunity in early life. But human milk also contains human milk oligosaccharide or prebiotics, and those are the third most abundant component in human milk, and they contribute to nurture the early life microbiome. And human milk is also a source of bacteria, but at low concentration. So how does human milk or breast milk shape, therefore, the early life microbiome? I'd like to share with you this study in which they look at the effect of breastfeeding on the early life microbiome during the first 4 months of life. So what you can see here, that over the first 4 months of life, when those babies, they were fully exclusively breastfed, you can see that the microbiome was mainly enriched in bifidobacterium, but not any type of bifidobacterium species. It was B. longum, Bifidobacterium longum, Bifidobacterium bifidum, and Bifidobacterium breve. Those 3 species of Bifidobacterium, they are what we call the human infant type Bifidobacterium species. So they are the ones that are transmitted from generation to generation, from grandmother to mother to granddaughter. So it's a maternal microbial legacy. And they are the only one that have the ability to consume, to utilize the human milk oligosaccharides that are present in human milk. So based on the scientific knowledge, insight on human milk, but also on the early life microbiome, here at Danone Nutrition Research, we have translated those insight, those knowledge into a specific nutritional innovation, a specific prebiotic mixture, short-chain GOS and long-chain FOS. Short-chain GOS that we derive from lactose and long-chain FOS that we derive from sucrose. And we combine them, those 2 active ingredients, in this ratio of 9:1. Why? Well, if you analyze the human milk oligosaccharides that are present in human milk with a specific toolbox, you will see that human milk actually presents a high level of short chain structure and a low level of long chain structure in a ratio of 9:1. That's why we use the same ratio of 9:1 with a specific active ingredient. So after designing the specific active ingredient, the next step was to determine safety and efficacy in clinical studies. So this is what I want to share here. So in this study, what we did, we compare 4 groups of babies, a group of babies fully breastfed, and 3 groups of babies, one exposed to a formula without any prebiotic, one exposed to a prebiotic formula at this concentration of the prebiotic, and another group of baby exposed to a prebiotic formula with this concentration of short-chain long-chain FOS. So in this study, we collected the stool samples of those babies, and after collecting those stool samples, we use a specific toolbox to detect and quantify the bifidobacterium in those stool samples. So what you can see here is that with this concentration of prebiotic, 0.8 per gram per 100 ml, we were able to emulate the similar concentration of bifidobacteria, similar to the one found in breastfed babies. So after detecting, quantifying the bifidobacterium in those stool samples of those babies. We also use a specific toolbox to analyze the microbial metabolite, so the molecules that are produced by those bacteria in the stool samples. What you can see here is that it's in the prebiotic group, the short-chain long-chain phos group, and in the breastfeeding group, those two groups of babies where we could detect the highest level of acetate. And this makes sense because those two groups of babies, they were the one that has the highest level of bifidobacterium. And if they have bifidobacterium, those bifidobacterium, they are active. They can utilize, consume the human milk oligosaccharide, the prebiotics. And by consuming the human milk oligosaccharide, the prebiotic, they do what we call fermentation. And the end product of fermentation is acetate or acetic acid. And this molecule, acetate or acetic acid, contribute to reduce the pH of the gut environment. So the pH of the stool become more acidic, and this acidity is known to prevent the growth of the opportunistic pathogen. And this is what we demonstrate here when we compare two groups of babies exposed either to a control formula and to a prebiotic formula. We also collected the stool sample of those babies, and we observed that in the prebiotic group, we could detect the lowest level of opportunistic pathogen. So after showing efficacy of the prebiotic effect on the bifidobacterium, on the prevention of the growth of the opportunistic pathogen, do we have any actually clinical endpoints? So this is what I want to share you in this study, where we expose infants at risk of developing atopic dermatitis in early life. We expose them to our prebiotic formula in early life. And what we observe is that compared to the control group, those infants that were exposed to a prebiotic formula, they show a lowest cumulative incidence of atopic dermatitis at 6 and 24 months of age. So I shared with you earlier that human milk contains human milk oligosaccharide or prebiotics, but human milk is also a source of bacteria, but at very low concentration. So in terms of innovation, here at Danone, we have recently developed a new active ingredient by combining a prebiotic mixture with a specific probiotic strains, which is called Bifidobacterium breve M16V. So remember, I shared with you earlier that the species Bifidobacterium breve is one of the human infant type Bifidobacterium species that are transmitted from generation to generation. It's a maternal microbial legacy. So both active ingredients, they have been well documented with safety dossier and efficacy data. So safety, efficacy data with preclinical and clinical evidence, with several independent studies showing that those two active ingredients can modulate positively the early life microbiome, but also have beneficial role in allergy prevention and treatment. And I'd like to share with you why we selected this specific probiotic strain, Bifidobacterium breve M16V. So currently, this specific probiotic strain is currently being used in clinical practice, especially in NICU, to prevent the development of necrotizing enterocolitis in premature babies, in preterm babies. And as I shared with you earlier, this strain is known to have beneficial effect on allergy prevention and treatment. And it has been demonstrated in preclinical and also clinical studies. I'd like to share with you a recent study where we wanted to determine the effect of a specific infant formula with our symbiotic mixture. And here we wanted to compare two concentrations of the probiotic strains, one at 10 to the 6 CFU per ml and another one at 10 to the 4 CFU per ml. And this is a concentration which was comparable to the one found in human milk. So in this study, the healthy babies, they were recruited at 6 to 8 weeks of age. The intervention was for 6 weeks. And we have 4 groups of babies, breastfed babies, a group of babies exposed to a high concentration of the probiotic strain, another one exposed to a concentration of the probiotic similar to the one found in human milk, and a control group without any symbiotic. So in this study, we collected the stool samples at baseline and at the end of the intervention in order to determine the efficacy of the intervention. So these are the outcome of this study. So this is a reflection of the baby microbiome 6 weeks. So after 6 weeks of intervention. So the dark dot represents the breastfed babies. The green dot, the babies exposed to the control formula without any symbiotic, prebiotic and probiotic. The blue dot represents the baby exposed to the symbiotic formula with the high concentration of probiotic, and the red dot, baby exposed to the symbiotic formula with a low concentration, so similar to the one found in human milk. What you can see here is that at the end of the intervention, the red, the blue dot, and the green dot, no, sorry, the blue dot, the red dot, and the dark dot, so they tend to cluster on this side of the plot. So the two symbiotic groups, blue and red, and also the exclusively breastfed baby, the dark dot here, that tend to cluster on this side of the plot. So this suggests that they share similar bacterial collection or microbiome collection. The microbiome was mainly driven by bifidobacteria. So you can see here also, we were able also to detect the probiotic strain and also the species B. breve. And also we also measure in the stool samples specific microbial metabolites such as acetate and lactate. And this makes sense because those three groups of babies, they show the highest level of bifidobacterium. So the baby that were exclusively breastfed and the two groups of babies that were exposed to the symbiotic formula. So they have higher level of bifidobacterium. The bifidobacterium that were active, they were able to consume the prebiotics, the human milk oligosaccharide, and they did what we call fermentation. And one of the end product of fermentation of the human milk oligosaccharide or the prebiotic mixture is to derive acetate and lactate. And those two, acetate or lactate, or lactic acid or acetic acid, they contribute to reduce the pH of the gut environment. So the gut environment is more acidic. And this is what we observe here, that it's in the control babies, so the green dot, the control babies exposed to the control formula, where we could detect the highest pH, so less acidic pH, and the microbiome was also enriched in opportunistic pathogens such as here Clostridium difficile. So beside this study, I'd like to share with you another study in which we determine the effect of a specific symbiotic formula in babies with atopic dermatitis, so in babies with eczema. So those babies with eczema, they were exposed to a symbiotic formula for 12 weeks. And what we observe is that in a specific group of babies, so children with IgE-associated atopic dermatitis, after 12 weeks of exposure to a symbiotic formula, we show that those babies, at the end of intervention, they show less symptom or less severity of eczema. So the delta score was higher in those babies, so meaning that the severity of eczema was improved in those babies that were exposed to a symbiotic formula. In this study, we also collected the stool samples of those babies, and we also demonstrate that the symbiotic could also increase the level of bifidobacterium. So once a baby is introduced to weaning, to solid food, what happened? How does solid food or weaning food contribute to shape the early life of the baby microbiome? So if you look at the literature, there is not a lot of data that's shown that depict how the solid food or weaning food actually modulate the gut microbiome. But I'd like to share with you these graphs that are extracted from this review paper that basically summarize some of the key findings on the impact of weaning on the early life microbiome. So what you can see here is that during the first 4 to 6 months of life, when the baby is exclusively breastfed, you can see that the baby microbiome is mainly dominated by bifidobacterium, here indicated by the pink curve. And once the baby is introduced to solid food, to weaning food between 4 to 6 months of age, you can see that other group of bacteria start to increase, such as the Lacnospiraceae, the orange curve, or the Rhinococcaceae, the brown curve. For instance, those two groups of bacteria, Lacnospiraceae or Rhinococcaceae, they encompass specific group of bacteria that have the ability to digest the fibers that are present in plant-based food. And we know that those bacteria, how do they digest those fibers that are present in plant-based food? They do that by doing fermentation. So they ferment the fibers that are present in those plant-based food, and the end product of the fermentation is short-chain fatty acid, and one of the dominant short-chain fatty acid that is produced through the fermentation of those fibers is butyrate. And butyrate in early life has a key role in strengthening the intestinal barrier, but also butyrate has a key role in regulating positively the immune system. So these data indicate, therefore, that in early life, there is what we call a pattern of successive microbial colonization, with first establishment of the microbes that have the ability to consume the human milk oligosaccharide that are present in breast milk and human milk, followed up by the establishment of the butyrate producer, so establishment of the bacteria that have the ability to consume, to metabolize the fibers that are present in plant-based food, and after that to produce butyrate. So therefore, what happens if this pattern of successive microbial colonization, is compromised? What happens if this pattern of microbial colonization is compromised in early life? Well, we have clues from cohort studies. If you look at the literature, there are now evidence from 7 independent birth cohorts from different geographical locations, from North America, Europe, and Southeast Asia. 7 birth cohorts where in those studies, they all look at the baby microbiome, the early life microbiome. And what they observe is that babies that develop allergy in early life, they have a microbiome depleted from those bacteria that have the ability to produce butyrate. So bacteria that have the ability to digest the fibers that are present in plant-based food. And to translate that into clinical endpoint, if you look at the literature, there is now a growing body of evidence that indicate that a healthy diet, so a diet rich in plant-based food in the first year of life with plenty of fruit, vegetables, and home-cooked food, is negatively associated with allergy. So remember, we are what we eat, but we are also what our microbiome does with what we eat. So those are my key summaries. So we are always told that we should preserve the biodiversity that surrounds us, but we should also preserve our inner.
Okay, thank you, Mr. Christophe Lay. Untuk kesimpulannya saya bacakan sedikit ya, bahwa ternyata kita sebagai orang tua atau ibu juga tidak hanya kita memikirkan apa yang harus kita lakukan untuk anak kita, untuk bayi, tetapi juga bagaimana kita menyiapkan mikrobiota pada bayi, karena ternyata bayi atau infant ya sudah melakukan kontak dengan mikrobiom itu, baik dari saat dalam kandungan, kemudian pada saat kelahiran, dan kemudian pada saat kita memberikan ASI ya. Dan dikatakan di sini sudah banyak tadi Mr. Lay tadi memberikan beberapa penelitian bahwa sangat erat hubungannya antara perkembangan mikrobiota pada bayi dengan adanya perubahan atau perkembangan alergi pada bayi. Baik, thank you Mr. Lay for a very informative presentations, very interesting. And now we are going to have our discussion then. Yeah. So we start with kita akan mulai ada beberapa pertanyaan. We will start with Professor Zaki first. Karena di sini sudah ada beberapa pertanyaan yang ditujukan ke Prof. Zaki. Sudah ada yang Prof. Zaki jawab tadi, Prof, tetapi mungkin bisa dijelaskan kembali, Prof. Tadi pertanyaan dari Dr. Patricia Yulita, izin bertanya pada Prof. Zaki. Prof mengatakan kalau di anak diet tinggi lemak dan rendah serat akan menyebabkan dysbiosis yang berakibat negatif. Tapi bukankah pada anak di bawah 2 tahun justru direkomendasikan untuk diet tinggi lemak dan serat hanya sebagai pengenalan saja. Jadi sebenarnya mulai usia berapa, Prof, anak sebaiknya disarankan untuk diet tinggi serat dan rendah lemak? Dulu, Prof.
Boleh saya jawab langsung ya?
Ya.
Ya, oke. Jadi yang dimaksud tinggi serat adalah bukan serat dalam arti enzim, misalnya sayur-sayuran yang banyak berserat, bukan seperti itu. Yang di penelitian yang dilakukan adalah pemberian makanan secara natural, yaitu makanan jadi, yang dari bahan-bahan alami, dibandingkan dengan anak yang makan junk food yang dari pabrik semuanya. Ya, jadi tentunya serat di sini adalah secara proporsional sesuai dengan usianya. Jadi bukan betul-betul serat saja, karena serat saja pun nanti akan mengganggu penyerapan beberapa jenis mineral seperti asam pitat pada kedelai, itu mengganggu penyerapan zinc, penyerapan besi. Jadi berikanlah makanan secara alami, kecuali kalau terpaksa baru menggunakan makanan pabrikan misalnya. Ya, di penelitian juga gitu, dia membandingkan ibunya membuat sendiri dari buah sendiri, di jus sendiri, dibanding dengan makanan yang dia beli di pabrik. Jadi bukan serat dalam bentuk serat tinggi serat, bukan, dalam arti yang proporsional, ya. Saya kira itu, Dr.
Ya,
Beni.
terima kasih, Prof. Jadi tetap harus proporsional ya, Prof ya. Yang kedua dari Dr. Immaculata, izin bertanya, Prof, kalau tidak salah tadi dikatakan bahwa untuk live vaccine akan merangsang memory cell sehingga biasanya tidak perlu diulang. Sebentar.
Ya. Jadi karena sistem imun pada usia dini kan tadi saya katakan masih belum matur, sehingga perlu perangsangan yang kuat. Oleh karena itu, untuk vaksin yang dalam bentuk vaksin hidup kan perangsangannya lebih kuat. Tidak perlu diulang-ulang seperti yang inactivated. Contohnya DPT bisa kita berikan sampai 5 kali, 6 kali. Sedangkan campak cukup sekali, mungkin 2 kali diulang waktu masa sekolah. BCG cukup sekali. Jadi itu yang dimaksud dengan bahwa live vaksin lebih kuat perangsang memori dibanding yang inactivated. Ya.
Oke. Ya, terima kasih, Prof. Kemudian pertanyaan dari Dr. Suni, Prof. Selamat siang, Prof. Zaki. Bagaimana pendapat Prof pada anak dengan imunodefisiensi, misalnya infeksi HIV, yang lahir dengan metode persalinan SC, kontraindikasi pemberian ASI dan penggunaan antibiotika yang lama, profilaksis yang lama. Adakah cara untuk memperbaiki mikrobiom pada kondisi tersebut, Prof?
Ya, jadi pemberian probiotik pada pasien HIV sebetulnya bukan kontraindikasi, ya selama dosisnya wajar-wajar saja dan kondisi HIV-nya bagus, bukan dalam keadaan imunosupresif yang berat. Walaupun ada satu laporan, ada overdosis dari probiotik, yaitu dia selama mendapatkan probiotik, juga minum yogurt tiap hari, terjadi bakteriemia, jadi langsung lactobacillus.
Agak
jelas ya suara saya
tadi, Prof? Iya, agak.
Ya, jadi pemberian probiotik pada HIV itu sebetulnya aman-aman saja sepanjang dosisnya sesuai dan kondisi anaknya lagi dalam keadaan baik. Ada satu laporan bakterimia dari bifidus dari lactobacillus akibat penggunaan yang berlebihan. Dia mendapat probiotik, kemudian tiap hari minum yogurt. Nah, bisa terjadi seperti itu ya.
Oke. Jadi sejauh itu,
Jadi,
ya.
secara sejauh ini aman-aman saja.
Oke. Ya, ini ada satu pertanyaan, Prof, dari Dr. Francisca Yohana. mohon izin bertanya Prof berkaitan dengan perkembangan imunitas pada bayi hingga anak. Apakah ada hubungan dengan rendahnya kasus COVID-19 yang berat pada kelompok ini?
Ya, sebetulnya kasus COVID, kenapa pada anak rendah? Itu karena reseptor pada anak masih sedikit, jadi tidak bisa dimasuki COVID seperti pada orang dewasa. Yang pertama itu. Kedua, sistem imun non spesifiknya juga masih rendah, sehingga tidak mampu berinflamasi seperti pada orang dewasa, sehingga gejalanya relatif ringan. Itu yang sering ya, kita dapatkan ya.
Jadi memang karena reseptornya ya Prof ya, memang
Ya,
pada anak relatif lebih sedikit. Ya.
Ya.
Ya. Ya, untuk pertanyaan dari yang dari chat baru sekian. Nanti kepada para teman sejawat yang ingin bertanya langsung kepada Prof Zaki dan Mr. Lei juga bisa bertanya secara tinggal bisa raise hand dan nanti akan saya persilahkan untuk bertanya secara langsung. Okay, but for Mr. Lei, so you mentioned about at the age of 3 months, 3 months of age. You mentioned that for infant with a normal infant, healthy infant, and infant with allergy conditions, they have different microbiome. You mentioned in your presentation. So, what do you think then? How early that we can do the interventions so we can reduce the possibility of allergy in those infants?
So thank you for your. Can you hear me? Yes.
Yeah. I can hear you.
Thank you for your question. So, because I have a kind of echo, that's why. Sorry. Okay. So basically, yes, if you look at the. Sorry, I have a kind of echo. I don't know here well.
I don't hear any echo from you, but you hear echo?
Yes, I hear an echo. Sorry for that.
Oh, okay. But I can hear you clearly.
Okay, good.
Okay.
So basically, if you look at the literature, there are more and more scientific studies from different research groups across the globe that indicate that a compromised microbiome in the first 3 months of life, the first 100 days of life, is a risk factor for allergy and obesity. And if you look at all those studies that, they have a consistent finding that those bacteria with the ability to consume breast milk sugar, they are basically depleted in those infants with a compromised microbiome. So now the question, when should we intervene? Well, if you compare those studies with the gold standard group, the breastfed baby, the vaginally born baby and a fully exclusively breastfed, we know already from the literature that the establishment of those breast milk sugar consumers, so the bifidobacterium, for instance, they establish already in the first day of life. So basically, they're already there in the first. So once a baby is born naturally, fully breastfed, the bifidobacterium, they're all there already during the first day of life. So meaning that they're already there to set up the right environment, gut environment, in order to support a healthy gut, but also to support the development of a healthy immune system in early life.
Okay, thank you, Mr. Lei. So there's also questions here from in the chat this is for you, I think.
Yes.
So this is from Dr. Gebiar Baskoro. So I think you can read it. Is there prebiotic dose to rise prebiotic growth? How is the dose? And then how can we get specific prebiotic for probiotic specific? Which must we be chosen between symbiotic or probiotics? For questions.
Okay, so regarding the prebiotic dose, so I share with you that here at the Nutrition Research, we have tested different concentration of the probiotic, and we have demonstrated that with the specific concentration of 0.8 gram per 100 ml, we could emulate the bifidogenic effect similar to the one observed in those babies who are exclusively breastfed. And then the second question, how can we get specific probiotic? So here, why we use, in Danone, why we combine, sorry, I have an echo, so I hear myself talking, sorry for that. So basically, why we combine this specific probiotic to specific. So in Danone, why we combine this combination of ghost force with the probiotic B. breve M16V, because we have done some internal research by testing different strains with a specific probiotic mixture, and we have demonstrated that this combination of ghost force plus M16V could actually alleviate some allergic symptoms in mice model. So we have done some preclinical study before that. And after that, we have, of course, like I shared with you earlier, we have done some clinical studies where we have demonstrated safety and efficacy in human, in baby subjects. Okay. And how to make that? So let me see. And that's the reason why we choose this combination, prebiotic and probiotics. So it is necessary to giving symbiotic children with picky eater. So that's an interesting question. So I guess, Francisca, that you are referring to the period when the babies are being weaned, I guess, introduced to exposed to solid food. So if you look at the literature, so once the baby is introduced to solid food, and if the mom, she still continue to breastfeed the babies, so you will still see the effect of breastfeeding on the baby microbiome. So meaning that you will still see the high level of bifidobacterium in the stool samples or in the microbiome of those babies, even though they are introduced to solid food. And there are even some studies that show that children, toddlers, who are still breastfed at more than 1 year of age. So we can still see the effect of breastfeeding. So meaning that you can still see bifidobacterium in the microbiome. So I hope that I kind of address your question.
Yeah, and then the next one is from Dr. Handoko Lois. Thank you, Mr. Lei, for the interesting presentation. I would like to ask, is it mean that the best supplementation of
okay. So thank you for this question. So indeed, there are different type of probiotics, and I think if you want to supplement babies with some bifidobacterium species, we should target some bifidobacterium species, as I shared with you earlier, the human infant type. So those that have the ability to consume the human milk oligosaccharide. And if you look at the microbiome of babies who are born vaginally and who are exclusively breastfed, you can see that there's a variety of combination of bifidobacterium species in those babies born vaginally and exclusively breastfed. So for instance, I can share with you, for instance, in our internal studies, we have observed that some babies who are born vaginally and exclusively breastfed, some babies, they are colonized with Bifidobacterium breve and Bifidobacterium longum. Some, they're only colonized with Bifidobacterium bifidum or Bifidobacterium breve. So no, it's there is no unique pattern. It's a kind of mix, a collection. So as long as you use the right probiotic, so meaning human infant type, so B. longum, B. breve, or B. bifidum. So those guys, remember they are microbial legacy. So they have the ability also to consume the human milk oligosaccharide that are present in human milk.
And then the second question, so how to make sure that the niche of the symbiotic supplementation enough to protect until arrive in the gut?
So basically, here in our study, we are using a dose of probiotics that is currently used in pediatrics, in pediatric setting, in clinical, in pediatric setting. So basically, the dose we are using is a dose used in clinical practice. So and we have shown that with this dose, we can modulate positively the microbiome of infants. And I shared with you earlier that we have done this clinical study where we use a probiotic concentration with a dose which is similar to the one found in human milk. So bacterial concentration found in human milk, which is low. And we demonstrate that even with this low dose, we can still boost the bifidobacterium in the stool, in the microbiome of those babies.
Okay. Okay, thank you, Mr. Lei. So I will go back to Profesor Zakiuddin. Ada pertanyaan, Prof, dari Dr. Usman. Apakah sensitasi terhadap alergen akan berubah seiring waktu? Sehingga pada pasien yang mengalami kasus alergi, jika kita melakukan pemeriksaan IgE RAS yang diulang akan memberikan hasil yang berbeda pada pemeriksaan yang berbeda.
Ya, betul, bisa berubah tergantung dari sensitisasinya. Contohnya misalnya alergi makanan umumnya akan berubah sejalan dengan maturitas saluran cerna. Contohnya alergi susu sapi. Alergi susu sapi walaupun awalnya tinggi sekali, mungkin kalau kita ulang setelah 3 tahun bisa menurun atau negatif. Ya. Atau sebaliknya walaupun masih tinggi, klinisnya sudah tidak ada. Jadi kalau kita dapatkan anak umur 5 tahun misalnya IgE positif terhadap susu sapi, positif 2 lah katakan atau 3. Kemudian kita provokasi dengan susu sapi biasanya sudah tidak ada gejala. Karena itu sisa sensitisasi sebelumnya, tetapi kalau dia mengonsumsi susu sapi, kemudian dicerna dengan baik di saluran cerna, maka diabsorpsi tidak membuat reaksi lagi. Jadi jangan terlalu buru-buru dengan hasil positif langsung mengeliminasi. Kita rekonfirmasi atau reanamnesis, kalau perlu dilakukan eliminasi provokasi. Atau sebaiknya ada makanan baru yang tadinya tidak pernah dikonsumsi waktu kita tes negatif, karena gejalanya tidak kunjung sembuh, kita ulang bisa jadi positif. Ya. Umumnya yang sering itu alergi makanan.
Ya, terima kasih Prof. Zakiuddin, karena waktu juga ya, kita hanya punya sekitar 3 menit lagi. Thank you for very interesting, very comprehensive explanation from Professor Zakiuddin and Mr. Christoph Ley. So because of the time, I have to close the Q&A session, and then I will read the conclusions ya. Jadi kesimpulannya bahwa tadi dari pemaparan Profesor Zaki yang pertama, bahwa kita harus diingatkan kembali ya tentang adanya perkembangan dari sistem imun pada bayi dan anak, di mana pada bayi, pada sistem imun kita akan terbagi menjadi baik yang non-spesifik maupun yang spesifik. Kemudian juga akan diingatkan kembali bahwa ya, untuk dari Profesor Ley tadi juga sudah disebutkan bahwa pentingnya pemberian simbiotik ya, prebiotik maupun probiotik pada bayi untuk membantu pembentukan dari sistem imun pada bayi dan anak, sehingga kita juga bisa membantu untuk menghindari anak terjangkiti untuk alerginya ya. Dan kemudian juga bahwa kontak terhadap mikrobiota pada bayi sudah terjadi sejak kehamilan, kemudian juga pada saat kelahiran, dan kemudian dilanjutkan dengan pemberian ASI ya. Dan tadi disebutkan juga untuk beberapa jenis mikrobiota yang baik, salah satunya misalnya Bifidobacterium, itu bisa kita perkenalkan lebih dini kepada bayi. Baik, untuk pada siang hari ini tadi sudah cukup banyak pertanyaan-pertanyaan yang sudah ditanya dan sudah dijawab dengan baik oleh para pembicara pakar kita pada siang hari ini. Untuk itu kita masuk ke pemutaran video credibility. Untuk itu saya persilahkan kepada panitia untuk memperlihatkan atau memutar video.
At Danone Nutricia Early Life Nutrition, we believe that the right nutrition during the first 1,000 days will positively affect short and long-term health outcomes. At Nutricia Research, we are making connections. Connections to pioneering nutritional concepts and scientific innovations with our multidisciplinary teams of over 400 scientists and experts of more than 35 nationalities. They work in life and nutrition science, as well as product development, packaging and technology, applying strict international quality standards. We are making connections across the globe, from our state-of-the-art research centre in the Netherlands to our satellite centre in Singapore, which anchor our global network of research facilities. To our partners from research institutes, universities and academic hospitals, ensuring that we stay at the cutting edge of science and technology in early life nutrition. It is these connections that keep us thriving, and after decades of research, we're still continuously pushing the boundaries of what can be achieved through nutrition in early life. As in the end, to ensure a healthy start in life, we use our connections and insights to develop healthy nutritional products with a pleasant consumer experience to meet the nutritional needs at each stage in the first 1,000 days. At Nutricia Research Early Life Nutrition, we bring science and innovation to early life.
Ya, baik, mengingatkan sekali lagi untuk para peserta, diharapkan kesediaannya untuk mengisi survei dengan mengklik, nanti ada link yang sudah disediakan, ya, http://bit.ly, kemudian survei PKB IKA 41, atau yang ada di bagian kolom chat, ya. Survei akan digunakan untuk saran dan masukan dari rangkaian acara hari ini dan untuk peningkatan di acara selanjutnya. Dan sekali lagi izinkan saya untuk mengucapkan terima kasih kepada para pembicara siang klinik online pada hari ini, kepada Profesor Dr. Aryono Hendarto, spesialis anak konsultan MPH, Dr. Yogi Prawira, spesialis anak konsultan, Profesor Dr. Zakiuddin Munasir, spesialis anak konsultan, and Mr. Crystal Play, PhD from Singapore. Menarik sekali pada acara online simposium yang kita adakan hari ini adalah hasil kerjasama dari KSM Kesehatan Anak Fakultas Kedokteran Universitas Indonesia, Rumah Sakit Umum Pusat Dr. Cipto Mangunkusumo dengan Nutrisia Sari Husada pada siang hari ini. Dengan berakhirnya sesi ilmiah, kita sampaikan, maka berakhir pula pertemuan kita pada hari ini. Saya ucapkan terima kasih kepada para narasumber dan tentunya teman sejawat, Bapak Ibu dokter yang telah hadir dalam simposium online ini dan yang telah ikut berpartisipasi secara aktif. Saya juga menginformasikan bahwa jadwal kegiatan online simposium yang akan datang akan kita adakan pada hari Sabtu 13 Maret 2021 pukul 13 sampai 14.30 dengan tema Towards an Optimized Management of United Airway Disease. So, jadwal kegiatan online simposium PKB KSM Kesehatan Anak FKUI-RSCM dapat dilihat pula di Instagram PKB pada @PKB IKA FKUI-RSCM. Demikian pada kegiatan pada siang hari ini, semoga bermanfaat. Saya ucapkan terima kasih dan sampai berjumpa pada kegiatan yang akan datang. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Terima kasih Dr. Berni.
Terima kasih Profesor Zaki. Thank you. Thanks a lot, Mr. Christoph Play, Dr. Yogi.
Bye.
Thank you.
Bye.